Have you ever stood in front of a mirror and wondered, why does it flip left and right but not up and down? It feels almost like the mirror is playing a trick on us, a small everyday magic that doesn't make sense. After all, when you raise your right hand, the reflection raises its left. But when you nod your head up and down, the mirror doesn't suddenly turn that upside down. It seems like a puzzle hidden in plain sight. So what's really happening here? To understand this, let's slow down and look at what a mirror actually does. A mirror doesn't care about left or right. It doesn't have a special switch that flips your body sideways. What it actually does is something much simpler and stranger. It reverses depth. It swaps front and back. When light leaves your face and hits the mirror bounces it straight back. Your nose is pointing toward the mirror, so in the reflection, your nose looks like it's pointing back at you. Every point of your body is reversed along the axis that is perpendicular to the mirror's surface. That's all. So why do we feel like it's left and right being swapped, not front and back? The answer isn't in the mirror. It's in us, how our brains interpret the situation. Here's a thought experiment. Imagine you're holding a piece of transparent paper with a big arrow drawn on it. You hold it up to a light so you can see the shadow of the arrow on the wall behind. If you flip the paper front to back, the arrow's shadow reverses. But if you just rotate the paper sideways, the arrow points in the opposite horizontal direction. The mirror works a bit like that, except it doesn't rotate anything. It just swaps the front-back axis. But when our brain tries to understand the reflection, it unconsciously imagines turning ourselves around to stand where the reflection is. And when we imagine turning, we usually rotate left to right. That mental rotation is what makes it feel like the mirror flipped our sides. Let's make it even clearer with a practical analogy. Picture yourself facing north. Your right hand points east. If you want to face the same way your reflection seems to be facing, you imagine turning around so you're facing south. But when you do that, east and west swap places. So your right hand is now pointing west. That's why it feels like the mirror has flipped left and right. But notice, in that same spin, up and down don't change. North becomes south, east becomes west, but up stays up and down stays down. That's the trick. The mirror doesn't flip left and right. It flips front and back. We are the ones who mentally rotate the situation and assign it as a sideways swap. But you might still ask, if it's just a front-back reversal, why don't we perceive it as that? Why don't we look into the mirror and say, oh, the reflection is inside out? The reason is that front and back don't feel symmetrical to us the way left and right do. Think about it. Your body is pretty symmetrical from the left side to the right side. 2 eyes, 2 ears, 2 hands. But front and back are completely different. One side has your face, the other side doesn't. So when the mirror swaps front and back, your brain can't easily map that onto your body. Instead, the brain chooses the simpler interpretation, left and right swapped. This is why the question feels so puzzling. Our perception is tricking us into describing the wrong flip. Here's another way to test it. Write a word on a piece of paper and hold it up to the mirror. The letters look backward. But why? Because when the front-back reversal happens, the part of the paper closest to the mirror appears on the farthest side in the reflection. It's like someone flipped the page and held it up to you. That's not left-right magic, it's depth reversal made visible. And yet, even knowing this, our intuition still screams, the mirror flips left and right. That's because humans don't naturally think in terms of three-dimensional coordinate systems. We think in terms of how our bodies move in space. Let's push the analogy further. Imagine you and your friend are standing face to face. You raise your right hand, your friend raises their left hand to mirror you. Does that mean your friend is left-right flipped? Not really. They just happen to be rotated 180 degrees relative to you. The same illusion happens with the mirror. It feels like another person facing you. So your brain uses the same mental model. Oh, that's me, but rotated, so my sides must be swapped. But the mirror isn't a person. It's not rotating. It's just reflecting light back in a straight line. The sideways swap is a mental shortcut. Now, here comes the eureka moment. The mirror doesn't flip left and right. It doesn't flip up and down. It flips in and out, front to back. Everything else is our brain reinterpreting that flip in the easiest way it knows how. And here's where it gets really fun. Once you know this, you can play little games with mirrors that reveal how your perception works. For example, if you set up 2 mirrors facing each other at right angles, suddenly text appears the right way around again. Why? Because one mirror reverses the front-back axis, and then the other mirror reverses it again, restoring the original orientation. You can even build a device called an ambigram mirror that shows text correctly without reversal because it manipulates this principle. This is also why a periscope in a submarine, which uses two mirrors, doesn't show the world backward. Each mirror reverses the axis, so two reversals cancel out. So what does this everyday curiosity teach us beyond just mirrors? It shows us how much our perception of reality depends not only on physics, but also on how our brains interpret physics. The world is throwing us raw data, light bouncing off objects, but our minds have to build a model that makes sense of it. Sometimes that model oversimplifies. Sometimes it mislabels what's happening, but the illusion itself reveals the machinery of our thinking. And once you see it, you can't unsee it. Next time you look into a mirror, you'll know the secret. It's not that the mirror flips your sides. It's that the mirror flips front and back, and your brain is the one playing the sideways trick. It's like discovering a magician's sleight of hand. The physics is simple, the psychology is the twist. And if you found this explanation eye-opening, imagine how many other everyday mysteries work the same way. Reality is always more surprising the closer you look. And here on How It Actually Works, that's exactly what we love doing, breaking down those puzzles that seem ordinary but hide extraordinary truths. If this made you see mirrors in a completely new way, share this with a friend, and don't forget to like and subscribe. Because every week, we explore another hidden key to understanding the world, and once you hold that key, everyday reality turns into a wonderland of discovery. But before we wrap up, let's go one level deeper, because this mirror puzzle is more than just a neat curiosity. It touches on something profound about how we understand directions in space itself. Think about this. Left and right don't exist in the physical world the way up and down do. Up and down are tied to gravity. No matter where you stand, you can always define what is up and what is down by pointing toward the sky or the ground. But left and right? They only exist in relation to you. If you turn around, what was your left is now your right. They're not absolute directions, they're personal. That's why the mirror feels like it messes with them. The mirror isn't flipping left and right. It's revealing that left and right are fragile relative concepts that depend on your point of view. Up and down, on the other hand, are anchored by the physical pull of gravity, so they feel permanent. This is why mirrors have become such a rich metaphor in philosophy and art. They don't just reflect the world, they expose how we, as observers, interpret the world. They remind us that perception isn't a passive camera feed. It's an active construction, built by our brains out of rules, shortcuts, and assumptions. You can even test this by looking in a mirror while lying sideways. If you tilt your head, suddenly the reflection feels strange, because now your brain struggles to decide what's up and down in the reflection. The rules you normally rely on get scrambled. It's another reminder that what feels obvious about space isn't always built into reality. It's built into us. Let's connect this to something practical. Ever wondered why ambulances have the word ambulance written backward on the front hood? It's so that when drivers look into their rearview mirrors, they don't see gibberish, they see the word correctly. The mirror reverses front and back, but because of how we position letters, that reversal makes the word readable again. This design literally saves lives because it takes advantage of how mirrors work and how our brains process reflections. Another real-world case. If you've ever used a smartphone front camera, you may have noticed that it shows a mirrored preview when you take a selfie. Then, when you check the saved photo, it looks different, like your face has changed sides. That's because the camera corrects the mirror effect to show you as others see you. But we often prefer the mirrored version, because that's the one we're used to from looking in the bathroom mirror every morning. This tiny design choice creates debates among app designers about whether to show people true to life or mirror true. Even technology has to negotiate with our perception. And there's another hidden layer here. Mirrors are one of the simplest optical devices, yet they open the door to incredibly advanced science. The principle of front-back reversal is the same one used in microscopes, telescopes, and even laser labs. When physicists align optical experiments, they constantly deal with this reversal effect. It's not just a bathroom curiosity, it's a building block of modern optics. Now, let's zoom out. The fact that we struggle with this question, why mirrors flip sideways but not vertically, reveals how human intuition can be misleading. We evolved to survive, not to perfectly understand geometry. Our ancestors didn't need to solve front-back transformations to gather food or avoid predators. So our brain built a quick and dirty set of rules for space. Those rules work most of the time, but when you add a mirror, they glitch. And when they glitch, they reveal the hidden code running underneath our perception. That's the beauty of asking questions about ordinary things. Why is the sky blue? Why does fire need gravity? Why does ice float? Or in this case, why do mirrors seem to flip left and right? Each puzzle is like a doorway. Behind it, you don't just find physics, you find a whole framework of how reality operates. You find the boundary between the external world and the way your mind interprets it. And here's something really cool. If an alien species evolved with completely different body symmetry, say they weren't bilaterally symmetrical like us, but radially symmetrical like a starfish, the question of mirrors flipping left and right might not even make sense to them. Their intuition about reflections could be totally different, because their mental model of space would be built on another foundation. That means this puzzle is not just about mirrors, it's about us, our biology, and the way evolution shaped the way we see. And once you see this, it changes the way you think about every reflection. A mirror becomes not just a piece of glass. It becomes a demonstration of how physics and psychology meet, how the universe sends us raw data, and how we bend that data into a story we can live with. So the next time someone asks you why mirrors flip left and right but not up and down, you can smile and say, actually they don't. They flip front and back. Your brain is the one doing the sideways trick. And when they look at you, half puzzled and half amazed, you'll see the same spark of wonder that science always delivers when we peel back the curtain. That's what makes questions like this so powerful. They remind us that the universe is not only stranger than we imagine, but sometimes stranger than we can imagine, until we dig a little deeper. And if you enjoyed this journey, imagine what else we can uncover together. Because this was just one mystery hiding in your bathroom mirror. Out there, in your kitchen, in your phone, even in the sky above your head, there are countless puzzles waiting to be unlocked. And that's exactly what we do here on How It Actually Works. So if you want more keys to reality, more hidden layers revealed, make sure to like this video, share it with a friend who loves good puzzles, and subscribe to the channel. Together we'll keep turning everyday moments into extraordinary insights. And with every reflection, every experiment, and every question, we'll move one step closer to understanding how the world actually works.